In this example, we are doing a two-sample t-test with unequal variances. So I've written down the information here. And you can see that the first standard deviation is 3.4 and the second one is 1.6. I'm going to say those are different enough. I felt more comfortable doing unequal variances. Okay, and you can see going through, I did things like check the conditions and everything. But someone had the question, how do we do the Satterthwaite degrees of freedom? So I've typed in this big long formula already because it is pretty long, takes a long time. So to start, notice that we're going to start with the variance of x. Notice that this is s squared. Sometimes you'll be given the standard deviation, which means you'll have to square to put it in here. Sometimes you might be given something where it's already the variance. So I could have given you like s squared for the current equals, let's see, what is 3.4 squared? I could have said that the variance was 11.56. Now, if you start with the variance, you don't have to square it to plug it in here because it will already be squared. But in our case, we start with standard deviation, so we'd have to square. So we'll do the first standard deviation squared over its sample size of 31. Plus we'll do the second variance, but we had standard deviation, so let's square it. So 1.6 squared over 35 squared. Now, for our denominator, notice this sx to the power of 4, which means for standard deviation, we have to raise it to the 4th power. Or if you have variance already, you could just square it, because it would already be s squared. So we'll do our first standard deviation of 3.4, but we have to raise it to the power of 4 over that sample size of 31 squared times the sample size minus 1. This is a very long, very gnarly looking formula, I know. Okay, my second standard deviation is 1.6. So we want to raise that to the power of 4, divided by its sample size of 35 squared times 35 minus 1. Again, I know this is long. It can be long to put in your calculator. I suggest doing the numerator first and then doing the denominator separately so you can compare to my answer. So don't forget things like the squared for the numerator. I almost left off that big squared. But I got 0.1989 for the top. I got 0.00479 for the bottom. That gives me 41.5. So go ahead and put that on your calculator a few times until you can get the right thing. Now keep in mind, on the exam, I won't actually make you do this because there are so many places you can mess up, and I understand that. So if it has to be Satterthwaite, I would give it to you. If it's going to be like equal variances, that's simpler. You can do that by yourself. But if it's going to be Satterthwaite for the unequal variances, I would just say use this degree of freedom.